Okay, time to look at resonating tubes. So yesterday we played with them a little. We played with both an open tube and a closed tube. Let's start with the open tube. Open means open at both ends. And in order to have resonance happening in a tube, it means there has to be a standing wave that occurs. The only way you can get a standing wave is if it's on an open end, there has to be a node. So put a dot at either end here. Okay? And so the smallest possible standing wave that we could get in this tube with a node at either end would be 1/2 wavelength. It would look like this. Now if it's a standing wave, remember it'll be flipping back and forth. So we do a broken dotted line on the other side. So it'll be flipping back and forth. So this is a 1/2 wavelength. So L, the length of the tube, has to be equal to a 1/2 lambda. And if we rearrange for lambda, then it means lambda must be equal to 2L. That becomes important when we think of V equals F lambda. We can rearrange this for F. F will equal V over lambda. And so if we sub in what lambda is equal to here, we find out that the first frequency that will cause resonance will be equal to V over 2L for an open tube. This is known as the fundamental frequency. Okay, fundamental frequency. It is sometimes also called the first harmonic, but you'll most often hear it called the fundamental frequency. Now, if we want to look at what would the next possible resonant frequency be, we would think about, remember when we were swinging the tube faster. Swinging the tube faster would mean there will be a higher frequency here. Higher frequency will mean smaller wavelength. And so what's going to happen then here is that you're going to get the next one up, and the only way you can have resonance with a smaller wavelength, the next smaller one up, would be if it was a full wavelength. Again, because it has to be a node at both ends. And again, it would be a standing wave, so this would be dotted. So here in this case, L would be equal to 2/2 lambdas. Over here it was just 1/2 lambda. If we went up to the third one, swinging faster again, we still need a node at both ends, and so the third one would have to have 3/2 lambdas. So we could write it as L equals 3/2 lambdas. And guess what the fourth one would have? The fourth one would also have to have a node at both ends. And so the second one had 2/2 lambdas, the third one had 3/2 lambdas. You might be able to guess that the fourth one is going to have 4/2 lambdas. Okay? So L will equal 4/1/2 lambdas. So if we rearrange each of these for lambda, here it'll be lambda is equal to 2/2L. Yes, I know that's just L, but I want to keep the halves in there. You'll see why in a minute. And here lambda would be equal to 2/3L. And here lambda will be equal to 2/4L. And yes, I know again that is really 1/2 L. But if we take them down here and we sub them into this equation that we rearranged, where F is equal to V over lambda, and if we sub in for lambda, then we get F is equal to V over 2/2L, which means F is going to be equal to 2V over 2L. But look, this V over 2L is what we found right there. It's F1. So this second F, this F2, is equal to 2 times F1. And then if we go to the next one, V over lambda, it will be V over 2/3L, flip and multiply. So it becomes 3V over 2L. And here's our V over 2L again. So my third F is just going to be 3 times F1. Guess what my fourth F is going to be? I'm sure you can never guess. Well, maybe you can. So it's V over 2 over 4L. Flip and multiply. So it becomes 4V over 2L. So the fourth F is just going to be 4 times F1. And we could keep going. The next one up would have another half wavelength added, and it would end up being 5 times the first one, and the next one 6 times. So notice up here that each time we move up, we're adding a half wavelength, okay, to get the next resonant frequency. What do you need to know here? So then for open tubes, if you understand the diagrams, then it will be easy to get the relationship between lambda and F for each one of them. And then the only other thing you need to know is how do you get the fundamental frequency and then these next frequencies. And these next frequencies are called the second harmonic, the third harmonic, the fourth harmonic, etc. Okay, they keep going. You will also sometimes hear them called the overtones. So this is sometimes called the first overtone, the second overtone, and the third overtone. I don't tend to use overtones as much because I think it's easier for you if I use harmonics, because the number on the harmonic matches the number that you have to multiply the original fundamental frequency by to get the new frequencies. Okay, so that's open tubes. Next video will be closed tubes.